Guys, this is a separate video. No introduction necessary. It is just something very quick that I wanted to discuss. This video is completely separate. It's very random, but I wanted to keep it out there as a record for myself and for the people who want to watch it, as it is pretty important. We all know about machine learning algorithms, right? Basic machine learning algorithms. And we know that there is a pre-processing step in almost all machine learning algorithms. So, I have taken this model for an example to explain the point that I'm about to make in about a minute. So, bear with me. So, this is the customer churn model. Made by the logistic regression. Okay, so this is day one of this is basically the first model out of the 30 days of machine learning playlist. You can check it out. So I'm going to skip right to what we want to discuss. So, when we get to the pre-processing, so this is our data. So basically, this is a binary classification problem on our hands. Basically, uh, we have to decide whether our model, whether a customer is going to churn or not going to churn. So like a 1-0, like a yes no kind of a problem. Okay, so which is why we have to do either binary encoding or label encoding in order to mark our targets. So this is how we have marked our targets. If the customer is going to churn, it will return yes, and yes means 1, no means 0. Simple as that. Now the most important part, okay, this is all redundant. This is all something you can learn somewhere else. But the most important part I wanted to discuss, it is so interesting and it is so simple, but I don't know why it's not discussed so clearly anywhere. Okay, it is this line right here, line number 44. Open your eyes, learn this line, memorize it if you want to, but this is the most important line in this entire code. Okay, why? Let's discuss it. So pd.getDummies, I think almost everyone will know what that does. pd.getDummies basically applies this label encoding that we wanted to apply on the entire dataset, which is inside this df. df was, right here. Simple, right? Now comes the main important thing. What is this drop first is equal to doing? This drop first is equal to true. What is it achieving? Now, listen. Whatever you're doing, put it down. Put it down. Believe me. No pens are required for this. No notebooks are required. Just look at me. Just look at my face. Okay, it's important. So whenever you go, if you go on Google right now, or if you go on ChatGPT right now, okay, and you write this exact line, copy it and paste it, and if you ask it, what is drop first is equal to true doing here? They are going to give you the same answer, and that answer is going to be that it is to avoid the dummy variable trap. Okay, again I'll repeat myself. They'll say it is to avoid the dummy variable trap. But the bad thing, and this is something I never liked about these systems, they never uh, you know they never give answers which provoke curiosity. They'll just give static answers. 1 plus 1, 2. They'll not tell you about 3 or about 4 or about the numbers after that. They are very static in this manner. I never liked it personally. So, coming back. So, drop first is equal to true. They'll tell you it is for the dummy variable trap, and they're correct. But what is the dummy variable trap? How does it happen? Why is it happening? Let's quickly discuss it. It is so simple. So, let me tell you something. Whenever we build a machine learning model, okay, whenever we try to solve a problem, we use these pre-built algorithms. Okay, any algorithm, it can be logistic regression, linear regression, decision tree, naive bayes, knn, k-means clustering, and whatnot, to solve a problem. Correct. But the thing is, one very important thing that is not profoundly discussed, but everyone kind of just assumes it, and it is the correct assumption. It is the assumption that these machine learning algorithms are independent in nature. Okay, meaning that when I am predicting y using mx plus c, y and basically the output y is not completely dependent on x. They are not 100% correlated. They are going to be somewhat correlated if it is a linear model. But the main thing that we assume in almost all prediction models is the independence of variables. Okay, the independence of variables. Just keep that in your mind. It will help us later. Now, coming back to drop first is equal to true. Okay, so I'll give you the simplest example to ever exist. Okay, now assume there is some data set, some school or college data set. Okay, and there are two genders in it. Okay, male and female. Now look at me. Okay, look at me. Like, no, not figuratively, literally look at me. Now, I am a male, right? I am a guy. So, if I say that if someone is a guy, I will write 0 there. Okay, and if someone is not a guy, if someone is a female, I will write 1 in there, just to denote it. Okay. Now, you tell me something. If I am a guy, can I be not a guy? Like, if I am a male, can I be a female? No, of course not. If I am a male, I am a male. Simple as that. If there is some girl out there who's watching this video, if you are a female, then you cannot be a male. Simple as that. So, do you get something out of this? Is something clicking inside of you? The point is that if I know who I am, if I know that I am a male, then I am definitely not a female. So basically what is happening here is that if I know about my variable, if I know what the male variable has to have the value in it, I can definitely use that and calculate the value for the female variable. Do you get my point? Let's say that only male or female are possible, okay? Which means that if the person is a male, you assign it a score of 0. And if the person is a female, you assign her a score of 1. So if the guy is a male, you will give him a 0, and if he is not a male, you will, so the point is that whenever we add the column of male and female, we get a 1 always, because it is either 0 or it is 1, and 0 plus 1 is 1. So the thing is, if I know the detail about the male variable column, I can definitely find the detail about the female variable column by subtracting it from 1. So, do you see something here? Suddenly, the independence of variables that we talked about is gone. I'll repeat it. Machine learning algorithms, machine learning models, whenever they are built, and I'm not saying built by the code that we write, when they were originally built by the person who invented them, they were built on the assumption that the variables inside the model are independent. But suddenly we just proved that the variables are not really independent. In fact, they are perfectly dependent on each other. It's either a male or it's a female. If it's a female, then I will 100% know that the person is not a male. And if I know the person is a male, then I will know 100% that the person is not a female. So I can use one variable and find the value or find the information about the other. Suddenly the independence is gone. Okay, take another example. Take the example of red, blue, and green. Let's say a data set has colors of red, blue, and green. Now, if I say that a color is not red and if a color is not green, then what it is going to be? It is going to be blue. Simple as that, because it is RGB. Simple. So, if I know the information about two of the variables, then I can definitely find the information about the third. Okay, these features are almost completely correlated with each other. These type of variables are called as multicollinear variables, and this property is called as multicollinearity. So do you remember collinearity from math? So I think I remember it from the definition of a triangle. So for a triangle, they used to say that 3 points which are non-collinear form a triangle. So collinear means the points which lie on a single line. So let's say this is my line. This is a pen right here. Assume it to be a line. Now if there are 3 points on it, I can call them to be collinear. And if there are more than 3, I can call it to be multicollinear or whatever. So this is the property of multicollinearity. Now, in our machine learning models, whenever we are doing the pre-processing steps, sometimes we come across such variables. In the churn model too, we come across such variables. Okay, either the customer is going to churn or the customer is not going to churn. If the customer is churning, then I can definitely say 100% that the answer for no is going to be 0. Why? Because if the customer is churning, then they are definitely not churning. Okay, so basically if I have the appropriate correct value of one variable, I don't need to go and see the value of the second variable. I can calculate it using the first. So in a way, the second variable is completely dependent on the first. Okay, this causes redundancy, basically repetition of data that we don't want, and secondly, it violates our original assumption about the independence of features. Okay, this is the dummy variable trap. Okay, this is called as the dummy variable trap. So the point is that if I have two features, let's say in this case the features are yes and no, And if I know the value of no and I can calculate the value of yes, or vice versa, then there is no point of keeping both of these variables. I am only going to keep one of these variables. Okay. Similarly for red, green and blue. Now if I know that the color is not red and the color is not green, then I 100% know that the color is going to be blue. So why should I keep three variables? I'm not going to keep red, green and blue three separate columns. I'm going to keep two variables. Because if I know the information about the first two, I can definitely use that information to find the third. Okay, so this is why this is called as the dummy variable trap. And what we do is we basically get rid of any one of the first columns, which is why eventually when we are doing the pre-processing step, we write this drop first is equal to true. That is the entire thought process, the intuition and the story behind it. Okay, so this is, very important. I think I've tried to say it before as well. I think that machine learning and basically all of CS, it rewards curiosity most of all. Like the code part and the algorithmic part, the math part is super interesting, but I think the more you poke into the places, asking questions where most people don't, you will get your answers very clearly, and you will just build a very sound understanding about everything. Now once you understand this dummy variable thing, there isn't a single chance that you're ever going to forget it anytime soon at all, because it's so simple. Now it's all conceptual. I'm not making you memorize something. It's all conceptual. Okay. So this is the intuition and the reasoning behind this drop first is equal to true. Okay. You are very welcome to read about it as well. I, as usual, will link an article uh, so that you can basically read about it. It's an article. It's a very simple 2-3 paragraph article about this same variable. And the thing that sort of ticked me off to make this video was that this is not explicitly discussed. If you go and search on YouTube, what is the dummy variable trap, you will find videos. If you search on the internet, what is the dummy variable trap, you will find it. But in the tutorials, when people are actually teaching the code, when they're actually telling you how to code, no one will explain this line by opening it up and telling you what is happening. Okay, I don't think any college too clearly discusses it, saying what this line is exactly doing. And many people, they go past it like it's nothing. Then one day you're sitting in, I don't know, let's say the biggest interview of your life for a machine learning role, and the interview asks you, okay, you wrote the code, well and good, you can have the job. Just answer one question for us. What does this drop first is equal to true do? And you're blank. So this is the reason for it. So comment out and tell me what are the topics you want clarity on, and if I'm aware about them, then I will try and spread the information as much as possible. Thank you.